Hey everyone, it's Azim. We are going to look at the difference of the histology of the different muscle types. There's smooth muscle, skeletal muscle, and cardiac muscle. Right now we're looking at a section of the intestines. We know this because if you look where my pointer is pointing, where it's darkest, this is all epithelium, and it looks all circular like this because these are cut villi. Then there's a layer deep to that. If this is a mucous membrane, then the connective tissue that's deep to the epithelium would be areolar connective tissue, so this is areolar. And then here we have another layer. And the intestines, one of its jobs is to push food forward. And so this is muscle. I know that given that it's the intestine, it's smooth muscle, but let's take a look at how we can identify smooth muscle. We're at 100x right now. We're at 400x. You can see that these cells are thin and spindly. Nuclei are spaced out. Very long, thin, spindly cells. This is smooth muscle. This is smooth muscle in the intestine. Let's take a look at smooth muscle in one more organ. We're at 100x. Whoop. Probably should start at 40. There we go. Okay, we are in the uterus. And all of this tissue is smooth muscle. Let's take a closer look. Here's 100x. You can see that, like in what we saw in the the intestines, that it was long and spindly, but sometimes it'll look rounder because it just depends on how it's cut. This is cut longitudinally. This is a cross-section of the fiber. Smooth muscle. Smooth muscle is smooth because it doesn't have what are called striations. Striations are organized proteins within muscle fibers, and you only find this in skeletal and cardiac. So this muscle, 100x right now, we can see very long bands. Like I'm tracing one cell. This is all one cell. Cells here are very, very long. We can see when we're at 400x, we can start to see the striations more clearly. Those lines that are going perpendicular to the fiber direction. So the fibers are going this direction, striations are going up and down. Really, really long fibers and cells that have multiple nuclei. There's one nucleus, there's another. This is just one really long cell. This is skeletal muscle. This is a longitudinal cut of skeletal muscle. If you want to see a cross-section cut of skeletal muscle, it'll look more like this. This is at 100x total. Here's 400x. You can see distinct fibers. They're rounder. So there's one, there's another, there's another, there's another. They're actually really long, but we just cut it on its head. We cut it in a cross section. Our last muscle type is cardiac, and cardiac, like skeletal, is striated, but it's organized very differently. Skeletal, the goal is to move bones, so they need to be long and they're very straight. I'm going 100x. The goal of cardiac is to beat with strength, but not too strong, and beat rhythmically. So cardiac cells are going to be smaller than skeletal, and they're going to be branched, going to 400x now. All right, we can see a single cell here, a single cardiac fiber here. Here's a nucleus. And here are its borders. These dark lines, here's one border, and then another border maybe up here. These cells, you can see that they're branching. So here's another good example. Here's a nucleus, and this cell branches off to one side, off to one side and off to the other side. Cardiac cells are branched, and that allows them to, when they contract, they pull a whole network of fibers together, so we can squeeze the heart rhythmically. Those dark lines that you see, those are called intercalated discs. Intercalated discs are where the cardiac cells join. And there's another feature there. Well, one way that they can pull on each other, you can find desmosomes there. Desmosomes are those linking junctions. You can also find gap junctions, and gap junctions allow ions to flow through so that you have a rhythmic contraction. I'm going to go to we are at 400x. If you look closely, you should be able to see striations. It's very faint, but if you look really closely, you can see striations within these cardiac cells.